Hello everyone, welcome to engineering study, and this is the last lecture of soil properties. Okay, and there is no conceptual part today. This is just the extension part of my last lecture, that is liquid limit, plastic limit and shrinkage limit. Okay, there are some definitions are remaining, that is shrinkage ratio, volumetric shrinkage and degree of shrinkage. First is shrinkage ratio, V1 minus V2 by Vd by W1 minus W2 percentage into 100%. Okay. If anyone want to write down the definition, write it down that it is defined as a ratio of decrease in volume of soil expressed as a percentage of its dry volume to the corresponding change in water content. Okay, just write the definition and go through the formula, you will understand it. Okay, now we will go the calculation part, that is how we will get the shrinkage ratio value in general form. Okay, so first, this is a first stage, fully 100% saturated soil, solid on water. Then you remove some amount of water from here. This is second stage, solid and water. But this is not a shrinkage stage. If you remove some amount of water from here, air may not occupy the space. Okay, so you can't tell that this is a shrinkage stage. This is a second stage from where you have removed some amount of water from the first stage. Okay, so this is V1 and this is V2. This is not a shrinkage stage. I am repeating again, this is not a shrinkage stage. Okay, first stage and second stage. And now water content in case of first stage, V1 minus Vs into gamma W by Ws. Water content means weight of water by weight of solid. So volume V1, volume of solid Vs, volume into unit weight, you will get the weight of water. V1 minus Vs into gamma W by Ws, that is weight of solid. And water content in second stage, V2 minus Vs into gamma W by Ws, okay, into 100%. And now if you subtract the water content in first stage from the water content in second stage, you will get this value, that is W1 percentage minus W2 percentage equals to V1 minus Vs minus V2 plus Vs by Ws into gamma W into 100. Okay, then you are getting the value V1 minus V2 by Ws into gamma W into 100. And now you put this value W1 percentage minus W2 percentage here, and then V1 minus V2 by Ws into gamma W. Then V1 minus V2 and V1 minus this V1 minus V2 will neglect each other. Then we are getting the value weight of solid by dry volume into 1 by gamma W. Okay, and this is weight of solid by volume means dry unit weight, gamma dry. So the value of shrinkage ratio is R equals to gamma dry by gamma W. Okay, important formula for competitive exam purpose. Next, volumetric shrinkage, V1 minus Vd by Vd into 100%. Okay, Vd means dry volume, V1 means the volume at the initial stage. Okay, that is volumetric shrinkage. And now degree of shrinkage, V1 minus Vd by V1. Same, Vd for dry volume and V1 volume for the initial stage into 100%. The difference is only here is Vd and here is V1. Remember it very carefully. Okay, so this two formula is also important. Now there is a tabulation form. How this degree, how you can identify the soil by the value of degree of shrinkage, and write down this tabulation form. Okay. And now consistency index, that is WL minus W by IP WL means liquid water content at liquid limit. IP means plasticity index, that is WL minus WP, and W means water content at current situation of soil. Okay, and then liquidity index, that is W minus WP by IP. WP means water content at plastic stage. Okay, the rest are same as consistency index, W and IP. So write all this down here. Okay, and next write a table I am giving on the screen. Okay, after liquidity index. Now toughness index. Okay, toughness index means IP by IF, that is plasticity index by flow index. IF means flow index. Write it here, IF, flow index. What is IF? You will understand at Casarende test of liquid limit. Okay, I will describe that IF part at there in the laboratory. Okay, so that is IF. And next write a 2 note here after toughness index, that is generally its value lies between 0 to 3. If for any soil its value less than 1, then the soil is easily crushable at its plastic limit. Okay, that means generally its value lies between 0 to 3. If for any soil its value less than 1, that means its toughness index is very less and the soil is easily crushable. Okay, and note 2, shear strength of soil at its plastic limit is approximately 100% more than the shear strength of soil at its liquid limit. Okay, because in the liquid limit soil has a tendency to flow. Okay, that's why the shear strength is very negligible in case of liquid limit. Okay, next shrinkage index, that is WP minus WSR, water content at plastic stage minus water content at shrinkage stage. Okay, WP minus WSR. Now THIXOTROPY, a next term is THIXOTROPY. It is very important. Okay, first go through the definition part. Over a period of time, soil regain a part of its lost strength on the account of rehabilitation of water molecules in the adsorbed layer of soil solid, but loss due to permanent structure of soil will not be regained by it. That means when you apply some load on the soil will compressed. Okay, and when you remove the load, the soil will not gain its previous strength or previous shape, but it will recover some amount of its previous strength. Okay, the amount recovered by the soil, the strength recovered by the soil is called THIXOTROPY. Look at here, this property of soil by virtue of its regained part of its lost strength at same water content and same volume of void is known as THIXOTROPY. So here soil is the initial stage here, then you apply some load and you make the strength level here. This is a graph, strength level here, and then you remove the load and soil will start regaining its previous strength. Okay, then you again apply some load, but here is a permanent deformation from here to here. Then you again apply some load and then after removing it will try to regain its strength, and but there will be a permanent deformation. This is called THIXOTROPY. Okay, so this term is also important, THIXOTROPY. Write the full note. Okay, and there is a graph between strength and time. Next, activity, that is IP by C. Before writing this formula, first write the definition of activity. Okay, I am dictating it. Skempton, Skempton, Skempton define a parameter termed as activity. Okay, it represents the swelling, swelling and shrinkage property of soil mass. It means activity shows compressibility and volume change of soil. The behavior of soil depends upon the clay mineral and the water content present in it. Okay. So activity defined as a ratio of plasticity index and clay mineral. That means the particles are finer than 2 micron sieve. Okay. So write the full note and then go through this formula IP by C. Write down here IP means plasticity index and C means clay particle. Then that means whose size is less than 2 micron. Okay. Then write this table: activity and soil. If activity value less than 0.75, it is inactive. If in this range, it is normal. If greater than 1.25, then it is active soil. Okay. So this is the end of soil property, and next I will give 2-3 workbooks in my channel and solve it, and then I will describe and I will discuss with you all the workbook. Okay, thank you.